Welcome back. My name is Susale Mohana. I am a maths teacher who has considerable experience teaching A-level, to put it precisely 50 years of teaching A-level maths. I'm just recording a number of lessons to cover the whole of A-level pure maths to help you revise and go over what you have been taught in school. This is not a replacement of what's happening in school. This is in addition to what's happening in school. Right. We were doing some numerical methods, mainly how to solve f of x equal to 0. I suddenly realized this is a typical example. A typical question would always say, show that f of x equal to 0 has only one real root, and show that this root is between this and this and this and this. And then it says about that, by you taking this iteration, show that. So, and you see, I have used a word, sufficient condition. See, there are two types of conditions. One is a necessary condition, another is a sufficient condition. So, it is enough. Sufficient condition means it is not necessary the condition should be there, but if the condition is there, it's enough to prove something. Like, if an equation f of x equal to 0 has only one real root, then it is enough for you to show that the derivative has no solutions. Why? See, f dash x equal to 0, if it has a solution, possibility is it could be a maximum point or a minimum point. So there could be more than one root. But if f dash of x is not equal to 0, meaning there are no stationary points, then if there are no stationary points, the gradient is always increasing or it's always decreasing. That means the graph is either going like that or the graph is going like that, cutting the x-axis in exactly one point, so one real root. But it's also possible I can have a graph like that, if you want to, like that, umpteen stationary points, but only one point where. So, if it has a stationary point or has a number of stationary points, you can't automatically say it has only one real root. However, it's not necessary that it should not have a stationary point. But if it does not have a stationary point, it's enough. It is sufficient to show that the original equation has only one real root. Of course, there are other ways of doing it. The other way would be split the equation into a straight line and a curve. Show that there's only one point of intersection graphically. Could do that way as well, but this could be easier. So in other words, if f dash of x equal to 0 has no real solutions, meaning no stationary point, then f of x equal to 0 has only one real root. Let me take an example on this. For example, so I will do a question on this and iteration as well. So I'll take an example. Show that, let me write it here. Example, because I need to do so much work, so I don't want it there. Show that the equation, what's the equation? X cube plus 2x squared minus 4 equal to 0 has only one real root. That's part A. Part B, find a number A such that A over 10 less than X less than A plus 1 over 10 has this root. Find an integer A. Okay. Part C, using linear interpolation over the interval, over this interval, find the root correct to 2 decimal places. That's a typical, so this one 2 marks, this one 2 marks, that one 3 marks. Roughly that would be a question. Alright. Of course there's a part D as well. Part D, starting with X equal to 1.15, use the iteration xn plus 1 equal to 4 minus 2xn squared power 1/3 to find the root correct to 3 decimal places. That would be another 3 marks. So that's a 10-mark question. What I'll do is, I will start solving here and I rub off as I solve. Look, so what f of x equal to x cube plus 2x squared minus 4, f dash of x equal to 3x squared plus 4x. The whole thing goes kaput. I should have taken something else. Okay, let me, I thought I took the wrong question. Not I didn't take the wrong question, but the sufficient condition doesn't work. Because it has roots. Suppose I make it x cube plus 2. Okay. X cube plus 2x minus 4. This root. Okay, that's fine. Let's delete the part D. That's all. The rest will work. X cube plus 2x minus 4 equals 0. So, dy by dx will be 3x squared plus 2. When you equate it to 0, x squared equal to minus 2 over 3. No solution. If therefore f of x equal to 0 has only one real root. There you are. This is what happens when I make up questions. I have to think. And sometimes I thought it would work. I wrote 2x squared instead of 2x. Very good. Now part B says I need to find an integer. What is f of 0? Minus 4. What is f of 1? 1 plus 2, 3 minus 4 is minus 1. What is f of 2? 2 cube is 8, 8 plus 4, 12, 12 minus 4 is 8. You see, change in sign of f of x. So I know it is minus 1 less than x less than 2. Sorry, 1 less than x less than 2 has a root. But do you see that a over 10? That means he wants the root to 1 decimal place, the interval. So indirectly they have told you to find an interval that is of width 1 decimal place. So look, as you can see, the root is closer to 1 than to 2. So try f of 1.1 will be 1.1 cube plus 2 times 1.1 minus 4. Shall we find out what it is? Okay, I forgot to turn on the stopwatch, so I'll turn it on maybe in 10 minutes. Okay, next. 1.1 cube plus 2.2 minus 4 is minus 0.469. What is f of 1.2? (1.2 cube minus 2 times 1.2 will be 2.4. Plus 0.128. So you see there is a chain there. So 11 over 10 less than x less than 12 over 10. So your a is 11. Indirectly they have asked you to do 1 decimal place root. Yeah, very good. So now I have proved a is 11. And he wants you to use linear interpolation. Okay. Linear interpolation. So draw a line. 1.1 f of 1.1, then 1.2 f of 1.2. Assume that to be a straight line, call it as x0. Call that as PQR. Gradient of PQ equals gradient of PR. What's gradient of PQ? 0 minus f of 1.1 over x minus 1.1 equal to f of 1.2 minus f of 1.1 over 1.2 minus 1.1. Having written that, I'll have to write the values. Let me work out what is f of 1.1. What is f of 1.1? It is 1.1 cube minus, plus 2 times 1.1 minus 4. 1.1 cube plus 2 times 1.1 minus 4 is minus 0.469. So that will be 0 minus 0.469 over x minus 1.1 equals, what is f of 1.2? So I need to do f of 1.2. So 1.2 cube plus 2 times 1.2 minus 4.128 is equal to 0.128 minus 0.469 divided by 0.1. When you cross multiply, don't open the brackets, use common sense. Look, This is minus and minus is a plus. When you multiply 0.1 with that, it becomes 0.0469 divided by, add these to 9 plus 8, 17, 1, 1 plus 6, 7, 7 plus 2, 9, 4 plus 1, 5 is equal to x minus 1.1. So x equal to 1.1 plus. That way, it's easy. Otherwise, you multiply by 0.597, x times 0.597, then 1.1 times 5.597, take it to the other side. You can make your life easier by simple tricks like this. So it is 0.0469 divided by 0.597 plus 1.1 is 1.17855. It is 1.17855, approximately 1.18. I just wanted to show you how you show in the exam. So find dy by dx, put dy by dx equal to 0, and then whereas, and then of course you can conclude if there are no roots that it has only one real root, the original equation. Whereas, let me go back to the question which I had. I will rub this off. It might change, it might remain the same, I'm not too sure. I'll go back to the question which I wrote. For C, use the iteration xn plus 1 equal to 4 minus 2xn squared power 1/3 with x naught equal to 1.15 to find the root to 4 decimal places. Okay, so I've taken the original question which I wrote because look, I said it is a sufficient condition. Remember, it is, if it has only one real root, it is not necessary. It is not necessary that it shouldn't have a stationary point. But if it doesn't have a stationary point, it's enough. Right? So there's a big distinction there, necessary and sufficient conditions. So let's look at that. What is f dash of x? Is 3x squared plus 4x, which is 3x times x plus 4, x times 3x plus 4 equated to 0. I get x equal to 0, x equal to minus 4 over 3. F of x is x cube plus 2x squared minus 4. Very good. Minus 4 over 3. When x is 0, y is minus 4. When x is minus 4 over 3, what is y? Y will be minus 64 over 27 plus 32 over 9 minus 4. 27 is LCM, minus 64 plus 96 minus 108. So 64, 100, 164, okay. 96 to 108 is minus 12, minus 70, 64, 74, 76, minus 76 by 27. Of course, you will use a calculator and get the answer. I could be wrong, but I'm not bothered. The only thing I'm interested in is, if you're asked to show that an equation has only one real root, yeah? So what I did was, I found dy by dx. If dy by dx equal to 0, I had no solution, I could have said, oh fine, there's only one real root. But it has solution, in which case, you find the stationary points, find their nature. What is f double dash of x? Is 6x plus 4. At x equal to 0, it is x equal to 0, what is f double dash of x? Plus 4 greater than 0, So this is minimum. What about at x equal to minus 4 over 3? It will be what? 6 times minus 8 plus 4 is minus 4, less than 0. So that is maximum. Yeah? So in other words, at 0, it's a minimum. At minus 4 over 3, it's a maximum. So therefore, at minus 4 over 3, minus 76 over 27 is a maximum. That's a minimum. So your graph will go like that. 1 real root. So to recollect or to go over, if you're asked to show that an equation has only one real root, find dy by dx. Put dy by dx equal to 0. If there are no solutions, conclude only one real root. If there are solutions for dy by dx equal to 0, find the stationary point, find their nature, draw a rough sketch, and show that the graph cuts the x-axis in only one point. That's how you proved it, right? I don't even need this. Let me see the time before I decide what I should do. This stupid thing, I don't know why it keeps. 10 minutes. Another for 14. Yeah. So I will just delete this. I don't even want to do that because I've just shown you linear interpolation. So I don't want to do that. So look, you're being given it's an iterative formula. So what's the formula given? xn plus 1 equal to 4 minus 2xn squared to the power 1/3. And you have to start with x naught equals 1.5. Put n as 0. What do you get? x1 equal to 4 minus 2x naught power 1/3. That is 4 minus 2 times 1.15. 1.15 squared power 1/3. As I told you, show the first substitution. So let me do this. Bracket 4 minus 2 times 1.15 squared close bracket power, oh no, sorry, shift cube root. Oh yeah, what did I do? Shift cube root, no, cube root bracket 4 minus 2 bracket 1.15 squared close bracket equal to 1.10657 something. I want 4 decimal places, 1.10657, so 1066. But the answer is 1.10657 blah blah blah. 2. This is the answer. What you do is, for x2 you do 4 minus 2 answer squared power 1/3. So I'll go back. Answer squared power 1/3 equal to 1.1575. See, this is the beauty of calculators for you. 1.1575. I've got the whole answer. Just put equal to 1.0970. x3 is 1.0970. Put equal to x4 is 1.1679. Put equal to x5 1.0835. Put x6 equal to 1.1821. Put x7 equal to 1.06400641. Put x8 equal to. You keep on doing. I think somewhere it will come. Somewhere you will get the answer. I don't want to go further. I think the answer is somewhere like 1 point. I have done it somewhere. I'm just trying to figure out what the answer should have been. I think the answer is 1.822 or so 1.1822 or something like that. Anyway, you can work out. Of course, I might have gone wrong in one of these calculations, but I'm not worried. I just wanted to show you the method. Okay? And you keep on doing till two answers are identical to the given place. But this question, this equation, I will keep it here. And remember, when I was doing it, what I'll do is when I do the next lesson, I'll keep that there because I'm going to do a different method of finding the roots. There, the root there, I'll show you how effective that method is using this as the example. Hello, I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.